Welcome, Michael Scholz.
Systems of the German Aerospace Center. And with my short talk, I will introduce you today to recently published OpenDRIVE datasets, which are now openly available. And these OpenDRIVE data are commonly referred to as highly detailed or high definition maps. Our first dataset covers around 35 kilometers of inner city sections in Wolfsburg, near the headquarters of German automotive company Volkswagen. And here 35 kilometers refer to the distance in both driving directions. And the surveying has been conducted through mobile mapping and funded in the project 5G Living Lab. You can find the original OpenDRIVE raw data for download under this digital object identifier, which is also nice to be cited and referred to in publications. And there we also cross-reference to some metadata on GeoNetwork. Our second dataset is covering around 13 kilometers of the inner city of Braunschweig, from the inner city ring road to the airport in the north. And the surveying has been conducted and funded by the research project Prizren. Now let's take a more detailed look into the data itself. So what does this HD mean in this case? Generally, when talking about HD datasets, it means that you find the overall traffic area subdivided geometrically into individual driving lanes and cycleways and pedestrian lanes, for example, or pedestrian walks. And so you have geometric boundaries and area information, and you also find logic links between each element. So between preceding and succeeding lane elements, you will find a logical link in the data. In addition to the drivable area, you find traffic infrastructure information, which can be positions of signals and signs. You can also find additional road marking information included in the dataset, and also location of poles, of lighting installations, and also of trees if you're interested in them. Regarding mapping accuracy, for both our datasets, we had the requirement that the absolute GNSS coordinate error is smaller than 20 centimeters, and that relative coordinate errors are always smaller than 5 centimeters within the dataset. The OpenDRIVE file format is pretty uncommon in the GIS world because it does not model geometries as we know them from simple feature world, where everything is a point, polygon, or a line string. Here in OpenDRIVE, we have a reference line, which is described through a cubic polynomial in space, and all other elements are described in relation to this cubic polynomial. This means that a lane is not geometrically modeled through ground control points, but described with the width information or a distance from the reference line. And it's not a constant value, but it can also be a cubic polynomial of the width of a lane. And infrastructure elements are also either referenced relatively to the reference line or might be positioned with absolute coordinates. As I mentioned before, this OpenDRIVE road description format comes from the automotive engineering domain, where it initially was used for driving simulations, where you require a highly detailed model of the road with all the information needed for querying in the simulation. And also it's used for generation of virtual environments and 3D models, which are then used in the driving simulator. And we also use such data for autonomous driving, where, for example, a shuttle is using an HD road-based map to calculate its route on lane level through a city or through an intersection. Another interesting application for OpenDRIVE data is traffic simulations, for example in Sumo, where you require a lane level or lane detailed network for inner cities in order to simulate your traffic behavior. OpenDRIVE itself is an open industry standard, so feel free to cooperate and to push your contribution. By now, finally, we have a small developer community growing, and under the posted links you'll find additional resources on datasets and processing libraries. In my following talk, I will give a small introduction about how to load OpenDRIVE datasets in the GDAL processing library, which enables you to include OpenDRIVE dataset in QGIS, for example. Thank you very much for listening and your interest. See you next time. Bye-bye. everybody, my name is Michael, and now I'm going to tell you how my student Gershon and I are using OpenDRIVE to convert OpenDRIVE road network datasets through the GDAL library into GIS-friendly geodata formats, which we can later use in QGIS, for example. This OpenDRIVE, this special format comes from the automotive engineering domain, where it was previously mostly used for driving simulation applications, where you are relying on a highly detailed virtual environment, covering also visual properties and also a very detailed road network, which has to compensate all information about the lanes, the road markings, infrastructure elements, traffic signals and signs, and so on. The data itself is hierarchically structured, where the road is the main element. So road also can have links to predecessors and successors. And inside the road, lanes are defined, which again can also have cross-references to other preceding, succeeding elements. And a signal which is bound to a road can also feature lane validity, and so on. At the junction, multiple roads connect to each other, which can also be additionally defined through linking properties. So it gets pretty complex pretty fast. And the roads in general are defined through an imaginary arbitrary reference line, which can be wherever. It's not necessarily defined that it has to be in the center of the road. It can be somewhere at the border of the road, for example. And all elements basically are referring to this reference line and are defined in relation to it. So the course of the reference line is the main element describing the course of the road, and it can be built from different parts, such as line snippets, spirals, and also complex cubic polynomials describing the road topography. And this ensures that we have a continuous geometry definition, which is very important for driving simulation and traffic simulation applications. When looking at the geometry, we can see that each geometric element of the reference line has discrete anchor points. Here we actually have UTM coordinates, and the course of the geometry is defined through a continuous geometry function, a mathematical function, which might also be a cubic polynomial, a complex one. Here we have just an arc with a constant curvature, but it can vary very much, especially if you have real-world data sets. So in order to convert data, you have to discretize the data, which is basically what at latest you have to do when visualizing the data, and everybody is doing it for OpenDRIVE sooner or later in order to get the data somewhere to be processed. We are using OpenDRIVE for it. Previously we were using our own custom library, but it turned out that OpenDRIVE recently gained a lot of interest, and many people are using it, and we also at the Institute use it in different applications. You can find it where you can find any open source software on GitHub. And so what we are doing basically, we are using OpenDRIVE to discretize the OpenDRIVE continuous geometry functions, which we then turn into simple features of the OGC standard. So OGR as part of GDAL enables us to convert these OpenDRIVE specific elements, such as signals and objects, for example, as point elements, and the plane view, the road reference line, and the lane boundaries, and so on, as line strings. And you could also have the lane polygons as the drivable surface, for example. So with the new CMake build process, everything is pretty easy integratable after figuring out how it works, and it compiles well under Linux and Windows. And what we get in the end is our extension of OpenDRIVE, of the GDAL library, which is very nice, because with this we can either directly load our OpenDRIVE datasets into QGIS, as I have done here previously, or we can convert OpenDRIVE datasets to shapefiles or GeoPackage or whatever you like. Right now we only have a small branch in our fork, but my dream is to get it as an official GDAL driver in future. So if you're interested, you can join our small community, you can contribute to the standard development, and also in future it might be an application domain extension to CTGML. So have a nice time and see you next time. Thanks a lot.